Okay, this is going to be another limit definition of a derivative, but it's going to be getting just a little bit more complicated, but not too much. They want us to find what our g prime of 2 is going to be for g of x being equal to the square root of x. Alright, so whenever you have something like g prime of 2, to start off with, we're going to take the derivative of our g of x, and then once we have the derivative, that's whenever we're going to substitute in our 2 to actually solve that. So, just go ahead and set everything up. Now we're going to have our g of x being equal to the square root of x. And so our limit definition, normally we say f of x, but it's just a different variable out front, so we can say that the g prime of x is going to be equal to the limit as h goes to 0 of our g, this time, of x plus h minus our g of x all over h. And like I said, it's no big deal or anything like that. The only thing that happened was now we're using a g instead of a f, so it's no big deal. Alright, so what does all this actually mean? Well, we just go through just like before. We're going to have g prime of x is going to be equal to, and the limit as h goes to 0, and since we have an x under the radical, we're going to plug x plus h in for it, so we're going to have the square root of x plus h minus our g of x, which is the square root of x all over h. Okay, so this looks a little complicated because we can't really do anything with it off the top of our head. But if we go through and we multiply by the conjugate, the top and bottom, since what we do to one we have to do to the other, so that way it's technically the same thing as multiplying it by 1, we can get this to where we can work with it a little bit. And so the conjugate is basically multiplying it by the same thing, except for you change the sign. So whenever we multiply through, we have the square root of x plus h minus the square root of x times its conjugate, which is the square root of x plus h plus the square root of x. And like I said, we have to do that to the top and bottom. Alright, and I will carry this over to another slide. Okay, so here's where we're sitting at. And I mean, if you wanted to, you could put parentheses around these just to kind of keep them separate so you don't get lost with it. Alright, so up top you can see that we have the difference of squares. And so basically what we're going to end up with is the first term, which is the square root of x plus h, and we're going to be squaring it, which is just going to leave us with the x plus h. And since our signs are different, we have a minus the square root of x plus the square root of x. And since our signs are opposite, whenever we go through and use the distributive property or the full method to solve this one, that just means that our middle term is going to disappear because we're going to have a positive and a negative, the same value, which is just going to give us 0, so we don't have to include that. And then we're going to end up with our last term, which is the square root of x. That's going to be squared, so the square root squared, it's just going to give us that term x, but because our signs are different, we're going to have a negative. So keeping that in mind, that's going to give us the limit as h goes to 0. And like I said, our first term, we're just going to get that minus our last term, and all of that is going to be over h times the square root of x plus h plus the square root of x, because we're just multiplying straight across. Alright, so now that we're right there, you can see that our x's are going to cancel each other out, and that would leave us with just a h over h times the square root of x plus h plus the square root of x. And as you can see, those h's are going to cancel each other out. So that's going to leave us with the limit, h goes to 0, of h goes to 0 of 1 over the square root of x plus h plus the square root of x. And then whenever you actually go through and you substitute 0 in for the h, that's going to leave us with 1 over the square root of x plus 0 plus the square root of x, which I'm pretty sure you can convince yourself is just 1 over 2 square root of x, because we have 2 of those on the bottom. And that's going to be equal to our g prime of x. Okay, so now that we have that, we can actually just go back and since we were trying to find g prime of 2, and then we're just going to substitute 2 in for x. So we say g prime of 2 is going to be equal to 1 over 2 times the square root of our x of 2, right there. So that's what we have. And if you wanted to clear out the bottom, if you didn't want a radical in the bottom, you could just multiply the top and bottom by the square root of 2. So that would be equal to the square root of 2 over 2 times the square root of 2 times the square root of 2 is just going to leave you with 2. So that would be equal to the square root of 2 over 4. So really, as far as in class, we could leave it like that. But if you wanted to actually clean it up and make it look nice and pretty, you could carry it on out and actually write it like that. Alright, we'll have another video up shortly.